And now let's do a few past paper questions which deals with approximation. The first part mostly is not about it. It's about the discrete random variable, and the following parts cover the approximation. So 30% of the residents of Winfield own an electric car. 3 residents are chosen at random. Find the probability that either all 3 own a car or none of them owns an electric car. So I can say that X, I am deliberately writing it to help you explain. You do not need to write this as your solution the first time. X, if I am saying this, the number of people who own an electric. So X is binomially distributed. 3 residents are chosen, so we are doing 3 trials, and the probability of success is 0.2. So these two statements, you do not need to write it as a part of your solution. This is just to help you understand notations and help you understand the variable itself. So the question is asking that either all 3 own a car or none of them. So either I get 3 successes, so success probability 3, or I get all 3 failures. Now 0.3 cube plus 0.7 cube 37 upon 100 or 0.37 is the probability that either none of them own a car or either all 3. Now moving on to the part which caters approximation, which is our actual focus of this video. So a random sample of 125 residents of Winfield is selected. Again, I'm taking X as the number of people who own an electric car. Use a suitable approximation to find the probability that more than 45 of these residents own an electric car. So if I wanted to do it binomially, I'll say X is binomially distributed 125 trials and the probability of success is 0.3. The question is asking me more than 45. This is the question. I have not solved any part of it. I have just broken this question down into mathematical notations to help you understand what the question is asking. So if I wanted to do it binomially, I would have started from 46 and then I would have had to take it all the way till 125, and I would have had to apply binomial for a number of times. So that is what the question gives us the option to approximate it as a normal distribution. So I'm calling that variable y, and so it is normally distributed. Now I need 2 things, the mean and the variance. Mean is NP, number of trials are 125, probability of success is 0.3. So my mean is 125 times 0.3, which is 37.5. And my variance is NPQ. So I'll just take the mean and I'll multiply it by the probability of failure, which is 0.7. And I end up getting 26.25. So if you're getting confused by NPQ, I'll just write NP into 1 minus P. So now I can say that my variable is normally distributed, 37.5 is the mean, and 26.25 is the variance. Now the question is asking me to calculate y. Now for greater than, I will not write 45. I was starting from 46 and going all the way to 125. If I take half extra in 46, I'll start from 45.5. Remember, this half extra is the extra in number line. So 45.5 is what I'll start with. Now this is, now I've transformed that entire continuous, that entire discrete variable into a continuous random. And now I can just solve it using simple means of normal. My Z will be, first I will find the Z value minus 37.5 divided by square root of 26 point. Now the Z value will be found using the calculator. In my another video, I've told you how you can find the probability by plugging in the Z value through the calculator. You can look at that video too, or if you have the table, you will be finding it through the. So my Z value, we take it correct to 3 decimal place, it is 1.561. 1.561. And I need to calculate the probability of Z greater than or equal to, it doesn't matter, 1.561. I always encourage students to draw sketches of your graph to understand so that you don't end up making an error. So this is your normally distributed variable. Mean is 0. This is your 1.561. And this is the probability that you are after. So the table does not cater to this probability, so we'll be finding it by subtracting the probability from one of Z is less than equal to 1.561. Let's go to the table and understand how we read it. The Z value is 1.5. 1.56 1. So I will add 1 in the last place value, 0.9407. Remember, this is the probability of the less than region of the left side, but we want the right side, so we'll be subtracting it from 1, and we will get our answer once we subtract it from 1. 1 minus 0.9407, which is 0.0593. 0.0593. So this is supposed to be the answer, 0.5. So that is how we can find probability by approximating a binomially distributed variable to a normal distributed. We'll do another question. I hope this one is clear. It's a very interesting question. Covers the discrete random variable, and the last part we will go to approximation. So in a game, a player attempts to score a goal by kicking a ball into the net. The probability that Leno scores a goal is 0.4 on any attempt, independently of all other attempts. Let the random variable x denotes the number of attempts that it takes Leno to score a goal. So what is he doing? Scores a goal. The random variable x denotes the number of attempts that it takes Leno to score a goal. So what is the question asking? Probability x is equals to 5. That means he scores a goal in the 5th attempt. That means the first 4 attempts he does not score a goal. So probability of failure to the power 4, and in the 5th attempt he scores a goal. This is a geometrically distributed variable. Point 6 to the power 4 2.4, which is 0.05184. 0.05184. So similarly, moving on to the next part. The question says that he scores a goal in between the 3rd and the 7th attempt. One way of doing it is he scores a goal in the 3rd attempt, he scores a goal in the 4th attempt, he scores a goal in the 5th attempt, he scores a goal in the 6th attempt, or he scores a goal in the 7th. This is a very conventional way that most of the students, average and below average, also prefer taking, but it does give you your answer. So scoring goal in the 3rd attempt would mean that first 2 failures and then success, 3 failures and then success, 4 failures and then success, 5 failures and then success, or 6 failures and then success. If you're confused about this, go through my video of the geometric distribution and you will be able to understand this. So 0.6 square into 0.4 plus 0.6 cube into 0.4 plus 0.6 0.6 cube into 0.4 plus 0.6 to the power 4 into 0.4 plus 0.6 to the power 5 into 0.4 plus 0.6 to the power 6 into 0.4. So this gives you 0.332 correct to 3 significance. Another way of doing it was an easier one. If I want to find 3, I could have just taken probability x is less than equal to 7 and subtracted x is less than 3. So how do I find success in less than 7? I'm taking all paths except the path of 7 failures. So that would mean 1 minus the path of 7 failures, 0.7 to the power. Sorry, not 0.7, failure is 0.6 minus. Now less than 3 would mean that 1 and 2, which will mean I can either find the success in the first one, 0.6, sorry, 0.4, or 0.6 into 0.4. Actually, we must get the same answer, 1 minus 0.6 to the power 7 minus 0.4 plus minus 0.4 plus 0.6 times 0.4. See, we get the same answer, 0.332. इसको भी 1 से minus करके we have found that too. So these are the first 2 parts of this question. We get to approximation. I hope this becomes good revision point for you. Find the probability that Leno scores his second goal on or before the 5th attempt. What does that mean? 5th attempt, he either scores his second goal or he scores his second goal before the 5th attempt. So find the probability that Leno scores his second goal on or before his 5th attempt. So let's find the probability second, third, fourth. So if you would have scored the goal in his second attempt, I'll find the probability of goal and goal. Both are goals, which will simply be 0.4 square. If he scores his second goal in the third attempt, I'll find probability of goal and goal not. Remember, this goal and goal not can be in any order. And the third one, will not write the probability, I'll just write goal and goal. This is goal and goal, both goals. And this is goal and goal not in any order. And then there is goal. So I'm just writing it for a clarification that this goal and goal not, the first two, from the first two, one of them is a goal and the other one is not, and this can happen in any order. So if I wanted to do this 0.4, there are two goals and there is one goal not. And this goal and goal not, the first two chances can happen in any order, which means I'll have to multiply them by 2 factor 2. So if he scores his second goal in the fourth attempt, then it's goal, goal not, and this can happen in any order. And the last one is goal for sure in the fourth attempt. So the one that I am just putting it in red color, this can happen in any order. We will count all these orders. So 0.4, 2 goals and 2 goals not. And the order is 3 factorial upon 2 factorial because 2 goals now, goal not are the same. And then there is goal, goal not, and again not a goal. And then in the fifth one, he scores a goal. Again, these four, the first four can happen in any order. Considering all their orders, I will say I have 2 goals and then 3 no goals, and then it's 4 factorial divided by 3. And all of these will be added. 0.4 square plus 0.4 square into 0.6 into 2 plus 0.4 square into 0.6 square into 3, 2 factorial upon 2 factorial will just be 3 plus 0.4 square and 0.6 cube into 4 factorial upon 3 factorial, just 4. So I should end up getting it as 2072 upon 3125. And leave the answer in fractions equal 2072 upon 3125. Now the main part that we have been so desperately waiting for, that is the approximation part, which is the main focus of today's video, but I hope the remaining parts would have served as a good revision point. Whatever I do when I approximate from discrete to normal, that is too easy to understand. You can just directly start with the normal part by finding your mean and variance. So Leno has 75 attempts to score a goal. This suitable approximation to find the probability that Leno scores more than 28 goals, but fewer than 35 goals. So he has 75 attempts. Now it is binomially distributed with 75 attempts, the probability of success being 0.4. The question is asking more than 28 goals and less than 35. So the question is telling us to approximate. We will find the mean, which is NE. So 75 times 0.4 is 30. And variance, which is this multiplied by 0.6, which is 18. So now I'm saying I've converted it into a continuous variable, normally distributed. Mean is 30, variance is 18. Now the question will become with the continuity correction. Remember, I would have started from 29 in this one. So taking half an extra would mean going to 28.5. And I would have ended on 34, taking half an extra from there. This is what we will end up with. Now, just making a rough normal table will normal graph, Gaussian bell curve will help you. So mean is 30. I want 34.5 and 28. I want the in between. First, I will find the Z value for 34.5. So 2.5 on square root of 18, 1.061. Probability Z is less than equal to 1.061. I will take the help of the table. 1.06 and 1 means adding to 0.58556. But this is the probability beyond the 34.5. Now I need to find the Z value for 28.5. So 28.5 minus 30 upon square root 80. So the Z value is minus 1. Upon square root of 18 minus 0.354. So in order to find Z value less than equal to minus 0.354, I'll just find 1 minus probability Z is less than equal to 0.35. 1 minus 0.354. 0.35 and 4 means adding 15, 68, 7. How do we add this? Let me show it to you. 6, 3, 6, 8. Without the decimal, just add 15, then put the decimal back 0.638. So it is 0.638. So 1 minus 0.6383 3617, 0.3617. This is a probability beyond this on the left of 28.5. I need the in-between values. So subtract both the probability 0.8556 minus 0.3617. 0.8556 minus answer 4939, 0.49. So that is how you can approximate from a binomial distribution to a normal distribution.